Greetings, students. We're continuing our series on balancing chemical equations for redox reactions. In the last video, I showed you how to balance under acidic conditions, and this video will show how to balance redox reactions under basic conditions. Again, I will remind you that there is a handout on the review session materials folder located under the content tab of Blackboard on balancing chemical equations. And I suggest you use this guide and you print this guide not only to follow during this video because it summarizes all the steps that I will talk about in this video, but also on your exams. All right, so now we're going to write a balanced equation for the reaction of solid zinc with the nitrate ion to the zinc ion and ammonia in basic solution. And here they give us the equation in order to balance this redox reaction. And we see that this is in basic solution. The interesting thing, students, is that we're going to follow all the steps that we did in order to balance this redox reaction in acidic conditions. We're just going to add more steps at the end. So we're going to follow steps 1 through 7 for balancing redox reactions under acidic conditions. I'm not going to project the steps here, but I am going to go step by step so you all can practice with me to see if you understood the steps of balancing under acidic conditions. So I want you all to participate with me, talk out loud while you watch this video and see if you really got it. So what is going to be the first step in balancing a redox reaction? I will pause for a couple of seconds and let's see if you can recall. The step is that we're going to have to write half reactions. And to do that, we need to look at the elements that are unique on both sides of the equation. In this case, it's zinc, and then nitrogen and nitrogen. So we're going to write half reactions with each of these species, grouped according to their colors. So that's what I'm doing now. Can we recall the second step of balancing redox reactions? I hope you recall that the first step is to balance all elements except oxygen and hydrogen. And we can look on this side of the half reaction, we can see we have one zinc atom and one zinc atom, balanced. And here we have one nitrogen atom and one nitrogen atom, balanced. We also have oxygen and hydrogen, but we don't look at those in step number 2. So therefore, this was already fine. We could have skipped step number 2. Step number 3, I hope you can, deduce, even if you don't remember, that if we've balanced every element except oxygen and hydrogen, the next step is to balance oxygen atoms. And here there are no oxygen atoms, so we'll be focusing strictly on this half reaction in blue. So to make it more clean, we're going to balance this by adding what? What do we add, students, in order to balance oxygen atoms? We add water molecules to the other side of the equation. So here we have 3 oxygen atoms. So how many water molecules am I going to add to this side? I hope you recall that we're going to add 3 water molecules, or 3 moles of water to this side, because 3 times 1 oxygen atom is 3 oxygen atoms. So now the oxygen atoms are balanced. So we've balanced every element except oxygen and hydrogen. Then we balanced oxygen. So all that's left to do is balance hydrogen. Therefore, how many hydrogen atoms am I going to have to add on this side? Specifically, I'm going to have to add protons. How many protons? Did you say 6 protons? And did you deduce that because we added 3 times 2 is 6? We'll also recall that we have ammonia here that has 3 hydrogen atoms. So we not only have these 6 atoms of hydrogen, we also have 3 more. So we have 9 hydrogen atoms in total. Therefore, on this side, I must add 9 protons. 9 protons to the left side of the equation. And now all my elements in both half reactions are balanced. The next step, students, can you remind me what the next step is once we've balanced all elements? The next step is to balance our charges, and we do that by taking the net charge on each side of the half reactions. So if we go to the top, we see that zinc here, it's solid zinc, it's neutral, it bears no charge. And here it's the zinc ion, it has a charge of +2, so it'll contribute a +2 net charge. In addition, at the bottom, we can see that the product side has no net charge because they're both neutral species, but on this side we have 9 protons, so that's going to be a +9 charge, and 1 nitrate ion, that's going to be -1 charge. So the net charge is +9 and -1 together. Here it's 0, so those are going to become +8. All right, students, so now we have found out what the net charge on the half reaction is, and we have to balance by adding electrons. We're going to add electrons, tell me, to the less positive side or to the more positive side. We're going to add electrons to the more positive side of both half reactions. In this case, it would be this side. It's more positive, plus 2 is greater than 0. So we're going to add 2 electrons to make this equal 0, because 2 moles of electrons will contribute -2 charge. So plus 2 and -2 combine to give me 0. In addition, here we're going to add 8 electrons so we can make the plus 8 equals 0. This is the more positive side. And 8 moles of electrons will give me a charge of -8, and these two will come together and give me 0. So now we have a net charge of 0 on all half reactions. Lastly, before we can add up the reactions together, we have to consider the number of electrons. Are the number of electrons equal in our half reactions? I hope you recognize that the answer is no. Here we had 8 electrons and here we had 2. So now we must multiply the whole half reaction by a factor that'll give me 8 electrons. So what times 2 will give me 8? The answer is 4. We're going to have to multiply the whole half reaction by 4. So 4 times 2 is 8, and we're going to distribute that 4 also to the other species. Each was 1 and 1, so it becomes 4 and 4. So now we have balanced everything. We've balanced our elements and our charges, so we're ready to add the equations together. So those were the steps under acidic conditions. I'm going to cancel out my electrons right now because we know there's 8 on the left and 8 on the right, so I can make those disappear. And I can add my half reactions together. Again, you highlight everything on the left side of the arrows and put that on the left side of your net equation. And then everything that we did not color, we put on the right side. Okay, so now to balance under basic conditions. We have to make sure that when we've added the equations together, the net equation is as simplified as possible. And here the ratio is 9 to 1 to 4 to 4 to 1 to 3, so there's no common denominator. No common factor. It's as balanced and as simplified as possible. So the next step, students, is to add hydroxide or OH ions to both sides of the equations in numbers equal to the number of proton ions. And that's because we're balancing under basic conditions. Hydroxide makes solutions basic, just like protons make solutions acidic. So I'm going to have to add OH ions, but to both sides of the equation. And I'm going to have to add them in equal number to the number of protons. So how many protons, students, are in this equation? We have 9 protons. So I'm going to have to add 9 hydroxide ions. And not only to the left side, but to the right side. That's where some students mess up. They forget to add to both sides. And why did I do that? Because on this fourth step, the side of the equation containing both proton and hydroxide ions, these combine to yield water molecules. It's a neutralization reaction. One hydroxide ion, or 1 mole of hydroxide, will react with 1 proton to give H2O. And we see H2O. So we're going to get water molecule in a neutralization reaction. It's an acid-base reaction. So these two are going to combine, and since 1 mole of hydroxide and 1 mole of a proton give me 1 mole of water, 9 moles of hydroxide and 9 moles of H plus will give me how many moles of water? I hope you answered 9 moles of water. 9 H2O molecules. Perfect. And lastly, students, the last step is to simplify the equation by removing extra water molecules. What do I mean? Well, here we now have 9 moles of water, 9 water molecules. But on this side, we already had 3 water molecules. So I need to simplify because that's extra water molecules. So I'm going to subtract both sides by the less number of water molecules. So I'm going to subtract both sides by minus 3 H2Os, minus 3 water molecules. So 3 minus 3 cancels, and 9 minus 3 gives me 6. And then finally, we check to see that the number of atoms and the total charges are balanced. In this case, if you actually wrote the elements and checked everything in the charges, everything is balanced. The only thing that I would add here at the end is to make sure that all the phases, all the states are included. So water is always in the liquid state and hydroxide is going to be in the aqueous state. So I'm going to add those states in parentheses. But students, that is how we balance redox reactions in basic conditions. So I hope you all participated with me while I was doing this. I felt a lot like Dora the Explorer, just asking questions to the screen. But it's all for your learning. So I recall and I will bring back to your attention that these steps that I just went over are summarized in the handout that I have posted under the Review Sessions Materials folder on Blackboard. So I just went over how to balance redox reactions in basic conditions. So we have completed our last objective for my Chapter 7 review session videos, which is to balance chemical equations for redox reactions using the half reaction method for both acidic and basic conditions. So ask yourself, do I understand how to do this? Do I understand how to balance these half reactions? Can I explain it to another person? And if you can, then that means after this self-evaluation that you are ready and that you've learned it. So if not, rewatch this video and practice as many times as you can. Your textbook has several practice problems that you can do with redox reactions. And that concludes my video. Thank you all very much.